セッション1の演題は
The title of session 1 is the future of the manufacturing industry. So I'd like to introduce the panelists first. National Center of Industry 4.0 Director, Mr. Roman Holly. Swedish Ministry of Enterprise and Innovation, the Director, Mr. Johan Havard. So from RI, News Case Task Force Chair, and he's also from ASBIL, Mr. Toru Ishikuma. And Dr. Milko Vordignen, who spoke earlier, and the Industrial Internet Consortium, Mr. William Diab, and from China, the Ms. Li Haifua. And the moderator is Mr. Fujino from NRI. So I hand it over to Mr. Fujino. Thank you. Good afternoon, ladies and gentlemen. My name is Fujino from NRI. So we discussed the future state of manufacturing industry, and I serve as a facilitator. And some of you have joined us with this session, so I'd like to introduce
today's panelist this morning. We have heard about China 2025 IIC and Fraunhofer. Li Haifua from Chinese government. Yeah. And William Diab from IIC mission. Dear Marco Bordinian from Fraunhofer Institute in Germany. And in this session, in addition to these three speakers, we also invite speakers from Sweden, Czech Republic, and RRI Ishikuma from Japan. Johan Havard of Sweden, Dr. Roman Hori of Czech Republic. Thank you. Toru Ishikuma, RRI from Japan. I think that it was very, very impressive for everyone to listen to the lectures in this morning. If I dare to mention a few keywords, would it be something like the following? First is intelligent manufacturing, digital production, versatile production, open innovation, standards, startup and accelerator, industry on campus, industrial analytics, testbed. Testbed means controlled experimentation platform. And finally, popularization of application of SME. And last is global ecosystem. Today, that I'm very happy to have a chance to discuss with specialists who have come from all over the world, the manufacturing industry in the future. I would like to set the following 3 points we should discuss. First is the manufacturing industry in the future, the major research theme, how to proceed the research. And the second point is the specific policy as industrial strategy and its scale. The third is expectation for Japanese companies and the Japanese government. So I would like to start on the first point. Number one is major research aim to realize the future manufacturing industry. Today, the other conference in Tokyo is a very special case. Most of the audience means to be Japanese. I'd like to start from Ishikuma, RRI, about the future manufacturing industry from the perspectives of the Japanese. Mr. Ishikuma, please kick off.
Thank you, Fujino-san. Okay, let me start with some material, and some insights, there's some idea of the vision, future vision concerning the industrial, manufacturing industries and others, yes, surrounding industries. I hope this will be the first, let's say, material for the discussion this afternoon, this session. Yes. First of all, all the material I'm going to explain is in Japanese, mostly. The one slide is in English. So let me speak also in Japanese a little bit, because the audience, I think most of them are Japanese. And I just want to interpret the morning sessions, the ministers, Society 5.0, down to this manufacturing industries level. So, すみません、じゃあちょっとここだけですけど。
So just for this part, I would like to explain this in Japanese. Sorry. So Vice Minister Mr. Nishimura explained the Society 5.0 and the Industrial 4.0. And I would like to map some of the points that were mentioned in his speech into some points in this presentation. Unfortunately, I didn't have any material for Vice Minister's speech, but this corresponds to the website of the Cabinet Office in Japan. So big data analytics and Industry 4.0 we implement, but what kind of society we would like to have? That's the final goal. So that our children or children's children can have a bright future, and so that they can have hopes. And to enable that, we use technologies, and there are several different areas, not just manufacturing, but agriculture is also healthcare and medical care. We use technology. And I would like to focus upon manufacturing here, but the first bullet shows using lots of information, we should be able to produce right goods for many people, and to be able to deliver them in time without any delay in delivery. And to be able to do that, we have, or by doing so, we can be more competitive, and we can solve the problem of a scarcity of labor, and also we can reduce the emission level. And if we can do that, then it can be called the Society 5.0. And there are 5 houses on the website of the Cabinet Office. So collaboration among suppliers and flexible production planning and inventory management, and fully utilizing collaboration, we can be efficient, and AI and robotics can contribute to streamlining of labor. Logistics should be also a part of it, so logistics should be more efficient. So those are the things that are discussed in Cabinet Office website. And so we need to create a new business model that can enable Society 5.0. So Japanese people love technologies, but the final purpose of connected industries is the implementation of Society 5.0. And there are 5 areas: mobility, manufacturing and bio-industry, material and plant security, and smart life. And using industry, we create a business model. So that's the model, or that's the definition of Society 5.0. And in this session, we are considering these, or our Japanese government is considering these aspects of Society 5.0. But in this session, what we discuss is manufacturing, and we use these terminologies in RRI. So there are lots of different processes, and it's like a human body. So different components and different cells, different parts are interconnected together, and they are working together. So 20 years later, 30 years later, we should have a society system that is similar to the human body. So very flexible, and production design or product design can be done very flexibly, and transportation planning can be very flexible. So for each order, you should be able to change your production planning on daily basis, or even hourly. You can change the design of a product or procedure, production procedure every day or every hour, or the assembly line or machine equipment for production can be changed on an hourly basis. And number 4 is optimization of transportation. So from any perspective, you can optimize everything. And B, so let's take a look into the field of production. So Kaizen should be possible in more granularity or smaller granularity. So there are allowances that are set, and based upon the data that you get out of the system, you should be able to add even more improvement while you are running the assembly line. And also the measurement method and control method of the process will change. And 100% availability of production system. So predictive maintenance is very important. So production assets or manufacturing assets are always up and running. So 100% availability is very important. So it is in English, so you can read this later. And we talk about the standardization in section 2, but connecting whatever we do have, we need to create additional value. So future systems should be like that. So these are the things that we are discussing in Japan. Yes. And you might have noticed, but I also included the RAMI for 4.0.
How do you feel about that, Mr. Ishikuma's presentation there?
So thanks again. And as I mentioned during my talk, I'm particularly positive towards giving Society 5.0 such a prominence. Probably we might run the risk of losing focus on believing that all those new technologies have the primary goal of making production more efficient. But as Ishikuma-san reminded us, they're here to improve our lives first. And if better production is a means to having fewer waste, to have better working conditions, this is again a means to an end and not the end itself, the better production. So this is definitely worth possibly being kept in mind in other regions, in other countries, in our national initiatives. Human factor as one primary goal. Then I like the analogy with the human body because it reminds me of the typical tension that there is between the efficiency, if you want, of a top-down design. So one single point, like the brain, if you wish to keep the analogy, that would decide how all the rest of the body operates. But then, as we notice with the startup ideas sourcing environment, it's also good to get the contribution from the bottom, to have your antennas down there distributed, that they can sense the stimuli very directly and can possibly have the micro improvements like a la Kaizen, as you mentioned, to improve the overall system. So I like the holistic view that you brought to the table. That was particularly interesting for me. And then one more thing that impressed me is the dimension on logistics, but not just on factory intralogistics. That is what I guess in production environment we typically think of, but like city logistics. So we know that with different disruptive trends from 3D printing, additive manufacturing, and the like, it might be that actually the production in the future does not happen behind the closed doors of a thing that might look modern, like Arena 2036, but is indeed still a centralized building in which you do manufacture, what should be the goods that in the future your consumers will want. Maybe all is distributed through the environment, micro factories in each neighborhood, and the intralogistics is actually within the city. So again, subcomponents that are sourced from distributed sites, and the factory is actually embedded as a thread within the social fabric of a city. So those are particularly interesting approaches that are peculiar, I think, to RRI. Thanks.
Yeah. I'd like to ask you some questions today. I think that it must be the Japanese vision must be very similar to the production of the future production 2036 of Arena 2036 you presented before. Are there any possibilities to collaborate with the Japan?
Yes, I believe that, again, a good cooperation is already coming to these events and hearing those interesting point of views that already gave us a few ideas or pointers to start discussion at home on how to possibly iterate on our concept to include those extra factors. As more specific cooperation, I think that going in the direction of the maps, the Industry 4.0 maps that other speakers mentioned this morning that can be shared, are another good starting point, but ultimately, it is probably on technology stacks that we need to cooperate to have, not to fight over my standards versus your standard versus his standard, or defining a bridge, because yes, our specifications are compatible, but we have those very, they might get pretty convoluted if we don't get some more standardization done in a really cooperative way. So it was also very good to hear that many activities are ongoing within the Industrial Internet Consortium that I was not fully aware of. So actually, it sort of diffuses my comment, because work is already ongoing on harmonizing the technology platforms. But attention should be really high there, because we don't want a proliferation of alternative standards to then have something bridging them. And that is the second step, I would say, after the input.
Standardization is very important. Yeah. Okay, so 次はリー・ハイファさんに聞いてみたいと思いますが、How did you feel about that, Mr. Ishikuma's presentation? That I think that China's 2025 is also a long-term big project with a view towards 100 years anniversary. That what I have understood today is that the Alliance of Industrial Internet (AII) was built. 10 testbeds, 20 testbeds, 25 best practice already started, in which about 10% is being participated with the foreign enterprises. I'm very surprised. Could you explain a little bit more about aims of this AII and its background with the comment of the President? Yeah.
Okay, thank you. It's very good question. Actually, I'd like to mention about the background to establish the AI. Actually, the industrial internet, this concept is introduced by GE. And I remember in 2 or 3 years ago, in 2014, yes, we initiate a study, the concept and about the industrial internet and the relevant technology and the trends. And where we discussed about this, we discussed if we call it industrial IoT or industrial internet. we think it's a bit different. Yes. At first, because we noticed that actually the industry emphasis on IoT technology a lot, but actually we think it's from technical aspect. And where we look, look at the Chinese situation, you know, Chinese has lots of very big internet companies such as Baidu, Alibaba, and yes, and we think in China we need to think how to take advantage of internet. This, yes. So at last, we use the term, the concept of industrial internet instead of industrial IoT, because IoT emphasis on technology. And second, how to promote, how to accelerate the development of industrial internet, because you know, to develop the industrial internet, you need to combine, yes, the ICT area with the manufacturing area is quite different. Where we talk with some enterprise experts, they do not understand cloud computing, big data. This is a big challenge. So it's quite important first to get yes, to set up a platform and to get experts and peoples together, and maybe to let them talk to each other, understand and share experience, and to know each other's requirements is quite important. So last year, as I introduced this morning, last year in February, under the guidance of MIT, we set up AI. CICT is leading AI, yes, leading the running of AI. And I think it's quite important platform, just like RI, maybe IC and Industry Industry 4.0. And actually, I think it's quite important. And currently, after 1.5 years, it has made a lot of achievement. And first, I think the most important is that people can get from the different area, manufacturing and ICT sectors, they can sit together and talk to each other, to understand each other, and to research on the new technologies together. Yes, maybe you have noticed that AI has, based on this collaboration and cooperation, we have made lots of achievements and published lots of papers, and I think it's technical papers and white papers. And it's quite important to let the industry to understand each other and to give guidance and instruction to the industry. It's quite important. And I think currently in China, after our efforts, 1.5 year efforts, the industrial internet, this concept is accepted in China widely. Yeah, because as frankly, at first, while we introduced industrial internet, maybe the manufacturing enterprise do not understand what's the meaning, the core idea about of the industry. But currently, this concept is widely accepted, and the enterprises have realized the data, the importance, and the collaboration between the different enterprise and how to use the internet, ICT technology, especially internet, to collaborate is quite important. And there are currently lots of practices on this aspect.
Yeah,
okay,
thank you. もう一人ちょっと聞いてみたいと思います。Mr. William, how do you feel about the presentation of Ms. Kuma? Oh, okay. Could you use my?
Thank you.
Because you presented the IIAF analytical framework, it must be very effective for the Japanese.
Yeah. So first of all,
because,
thank you for having me on the panel. I appreciate it, and I thought it was a great presentation. I was busy taking notes on what he was doing. So not surprisingly, I'm going to talk about analytics, But before I do that, I wanted to actually, one of the really nice things about your presentation that I liked is this concept of linking the business model down to the factory floor. And you really took that concept of how IT is becoming more and more involved in the operations, and how we talk about having insights on what to do, predictive maintenance down to the next level, which is basically real-time adjustments of your objectives, real-time adjustments of the design and manufacturing of the product, which I think is really where the holy grail, where we're all trying to go. As far as the general theme of analytics, I mean, like I said earlier today in my talk, I think big data analytics and AI are three sides of the same coin. We're basically trying to get value out of these entire deployments. In of itself, IoT and sensor networks aren't that interesting. It's the value you get out of it. So I think at least from my perspective, that slide that you showed some of the directions that you're going in, I think it was 203X. I think that was really really good.
So the real-time analytics is a keyword of your framework then, maybe. Yeah.
Absolutely.
Yeah. Thank you. それでは時間が迫ってますので、次のテーマ
Under the time constraint, we would like to move to the next topic. So next is to implement this, what kind of industrial policy we need to have. So now I'd like to invite Dr. Roman Holly.
From Czech Republic. Please share of the testbed at CIRRC, Czech Technical University, and the National Center for Industry 4.0, please. National Center, Industry 4.0 のナショナルセンターを作られて、かつ大学でも。
He founded the National Center for Industry 4.0, and he is teaching about this at the university.
Thank you, Fujino-san. And dear Minister, dear Secretary General, dear fellow speakers, ladies and gentlemen, it's really a great honor for me to be here with you. In fact, I must say it's the first time I made it to Japan, so really a personal adventure. I will try to make it short, but just have to mention that I'm sure you know, or should know, that the word robot was created in the Czech Republic by brothers Karel and Josef Čapek, so just the small promotion. But of course, not all the robots are made in the Czech Republic. This is just to show you some main buildings of Czech Technical University, which is the oldest university in the Czech Republic and probably in the world also, if I'm not mistaken. And just to give you a glimpse of what you could see in Prague, because I know that tourists, they love Prague, and also, of course, there are many Japanese tourists, but if you were not in Prague yet, maybe you could visit. This is just to give you a summary of what kind of research and education capacities are in Czech Technical University, which were part of it. So you can see like traditional faculties, civil engineering, mechanical engineering, my alma mater, of course, electrical engineering, very important, but also the faculties which didn't exist 20 years ago when I studied, or even more. So a new one, biomedical engineering, or of course the information technology. And also there are 5 institutes, which my institute, which is not visible, unfortunately. It's the Czech Institute for Informatics, Robotics, and Cybernetics is the youngest, but not the smallest. And you can see the picture of our director, Professor Vladimír Mařík, who unfortunately couldn't make it this time, but he was here last year, so maybe some of you could remember him. This is again the structure of the research groups in our institute. Again, of course, all, I think, are or could be connected to, as we call it in Europe or Czech Republic, Industry 4.0 or Industrial Internet of Things, robotics, intelligent systems, also platform, cyber physical system, and many others. Here you can see the main project activities at CIRC, at the institute. So you could see, you can imagine that most of them are funded by from national funds or from the EU funds, like Horizon 2020, or even the 7 framework projects. But also there are other sources or connections, like from US Missile Defense Agency, we have one project, or now the most current one is the Alexa Prize, and the result should be known, I think, today, because there was the final this week, and the Czech team from our institute made it to top 3 from more than 100 university teams in the world. So I wonder if they won or they were just second or third. And of course, I know that the leader of the team was quite afraid to win, because even they were evaluated as the best team in the semifinal, because he's afraid that students, they will just grab those millions of US dollars and they will stay in the United States, yeah, or somebody will buy them. So here you can see our the main projects for the future, even with the key personalities leading those projects. These are called excellent teams, and the condition was that the people, the heads of the projects, they had to come from abroad. So you can see that Mr. or Dr. Josef Urban, with the project of artificial intelligence and reasoning, he came from Paris, INRIA Institute, back to Czech Technical University. Dr. Josef Šivec from Project Intelligent Machine Perception. He came from back from Nijmegen University, and the Professor Robert Babuška, he came back from Technical University of Delft with the project of robotics for Industry 4.0. Here's just the small picture that, sorry, but there will be some real ones. That's just the original plan of our testbed, which is of course the key technology infrastructure of our national center, which is supported. The main partners are Siemens and Škoda Auto, and there are few Czech and German companies also supporting it, and there should be about 20 different machines, robots, of course, including. But the main strength of the testbed is its digital twin capabilities, or the virtual connections with other testbeds. And also the main objective is to connect the Czech SMEs with the global players, which we try to do. Just to show you the way to the creation of the National Center for Industry 4.0 at the Czech Republic. Of course, in 2013, the concept was introduced first in Germany. In 2016, the Czech National Initiative Industry 4.0 was submitted to the government and approved by the government. Later on, there were some workshops. And last year in August, the collaboration agreement between CIRC, the institute, and DFKI, the Research Institute for Artificial Intelligence in Saarbrücken, Germany, was signed. and also there was the mission this spring to Japan. And you can see, I think there are very important persons like professors and our prime minister change, but I think the most important are ladies. So on the left you can see behind the German Chancellor Angela Merkel, and I'm sure you all can recognize your imperial princess on the right side. Yeah, and in February the testbed was started to be developed, and in fact only in May the new building of the institute was opened this year, and in September, 4th September, of course, was the official opening of the National Center and testbed. And now you can see the picture a little bit, giving you the show. It's really combination of the reality of Industry 4.0 and also virtual and augmented reality. Just the picture from the opening with all our academic and industrial partners. In fact, the most of them are industry partners. You can see that we are an open platform, trying to combine really the academic institutions, industry leaders, and also associations and innovation centers. It was created, in fact, the bottom-up approach, not from the top-down, from the government. Even, of course, it's officially supported by the government, and it's like practical development of that national initiative of Industry 4.0. And so it's, I think, a nice example of a public-private partnership. Our main objectives, and now there you can see the picture of the testbed, how it looks like in reality. It's a promotion of the principles of Industry 4.0. So we are going to provide trainings, organizing conferences. That's maybe one of my lessons I will take home from Japan. It's maybe we could try to organize a really big event like this one, even it will be difficult in our Czech conditions. So different testbed, different universities. Here you can see just the logos of our funding partners. So really the key academic partners are Czech Technical University and the Technical University in Brno. And of course, I mentioned already Siemens and Škoda. Then there are the Chamber of Commerce, Czech Confederation of Industry, Innovation Centers, and the companies. So you can see that really quite well connected to German companies, which is Festo, KUKA, still I think we can call German company SAP, and the other ones are the Czech ones. Yeah, geographically, how we are connected. The National Center really tries to cover all the important places in the Czech Republic. Means there are planned 2 other testbeds to be created, one in Brno, in the south of Czech Republic, and one in Ostrava. That will be testbed in that northern eastern part of the Republic. And you can also see the connection, which is really also physical connection, because already was there in October, and also the virtual connection, because our testbed is virtually connected to the testbed of DFKI in Germany, Saarbrücken. Here, you can see our connection to Japan, which, of course, we all know is a very strong partner. There was, I mentioned, I think, German-Japanese Czech workshop in 2016 held in Prague. Professor Mařík was here last year, and there was the Czech robotic mission already mentioned in the spring. And there are nearly 100 Japanese manufacturing companies in the Czech Republic, of course, led mainly by Toyota and Panasonic and a few others. And yeah, and here you can see the picture from the ceremony of honorary doctorate received by Dr. Toyoda. I'm sure you all know, I think it was in 2006. And that's my last slide. I would like to stress it's really the open invitation. I feel a little bit it's maybe not shame, but a little bit missed opportunity, and I wonder why still we don't have any Japanese company on the board, the National Center or testbed, because there are quite few of them in the Czech Republic, but I guess that maybe, of course, maybe geographical, a little bit farther away, that Japanese companies could be a little bit more careful or shy than German companies, but there are the contacts with some of them, and I hope that my presentation here will help to really to get at least some Japanese companies on board. So you can see my contacts, and if you are interested, please contact me. We can exchange the cards and information. And on the picture, you can see that we are really, I think, and I try to be humble, but quite important or interesting place to visit, even for our ministers. And you can see by chance, the Minister of Foreign Affairs, Mr. Zaorálek. Behind him, there is the Minister of Education and Sport at our RoboBar, where we have the robotic barman and just receiving the drink from him. So that's our national center, our testbed, and thank you. Arigato.
Thank you very much. I'm very much impressed with your academic activities. You got the Alexa Prize. I'm very surprised. By the way, that
I don't know if you won.
University. By the way, that are there any possibility for the Japanese small and medium-sized enterprise to join the center or Industry 4.0?
Of course, it wasn't mentioned because, in fact, we just started officially. It was announced in September, and so I showed only the logo of the main partners, really the bigger companies. But that's our main objective, to support the Czech, but it can be also Japanese small companies, if there are such in the Czech Republic. The only condition is that they have to have the Czech legal entity. So, but any company is welcome, of course.
Thank you. So the time is limited. So next guest is Mr. Johan Harvard from Sweden. Please explain your strategy there. Faster transition to connected manufacturing.
Thank you very much, and thank you for inviting me. It's an honor to be here and to speak with you and all your colleagues here in the country. It's very inspiring as well to meet with Japanese manufacturers, which are really at the cutting edge of development. My name is Johan Harvard. I work at the Swedish Ministry of Enterprise and Innovation, so the Swedish METI. And my responsibility is the Swedish policies for connected industries. So I run those policies at the Swedish government. And I would say that's one of the best jobs in the Swedish government right now. Our Prime Minister has a background in the manufacturing industry. He's been working on the shop floor. So he really puts a big effort on smart manufacturing and boosting that. He knows the importance of driving change there. I would like to give you a very brief presentation of the Swedish policies currently. And if you just remember one thing from my presentation, I would like to underline some things here, that we all know that technology is extremely important. Without technology, we cannot make the progress that we see ahead of us. We know all the buzzwords with IIoT, artificial intelligence, cyber-physical systems, but technology is worth zero if it's not utilized. We have to use it. And technology is worth nothing without a business model. If no one pays for your technology and using it, it's worth nothing. So you might have wasted your resources developing technology. And also, technology and business model is not worth anything if you don't have the human skills to operate the technology and to work with it. So you have to train the humans. That's really, really essential. And also, lastly, even if you have technology, you have a business model and the humans, if you're too slow, it doesn't matter. So you also have to be fast in your development. You have to be able to take risk to move forward. You have to be able to fail and learn from failures and move forward. That's a key component in our policies. Just very briefly on Sweden, did you know that for 100 years ago, Sweden was one of the poorest countries in Europe? At the very bottom, one of the poorest countries in Europe. But many things have happened in 100 years. Sweden is today home to just 0.1% of the global population. It's a very small country, but still Sweden is at the very top in competitiveness in the world. So it doesn't matter which ranking list you look at, Sweden is top 3, top 5, top 10 in any of those rankings. For instance, here's one example of that from the World Economic Forum, where they have done the Global Competitiveness Index for many years. And in fact, only 7 countries in the world have been top 10 for the last 10 years. And there we find, for instance, Germany, the US, Japan, Sweden, and a few others. So Sweden is really one of the top countries in competitiveness in the world, and it's consistently so as well. I respect, yeah. It's quite nice. Sweden is a small country, but we have very big brands. We have companies which have made it throughout the world. And also, we're very proud to say also now that we have very fast and good startups. Did you know that on a per capita basis, Sweden and Stockholm is number 2 in the world on unicorn companies with a US billion-dollar valuation? It's Silicon Valley, and then comes Sweden and Stockholm, with Spotify, for instance, being one example of a global service really going fast. And all of these successful companies, they share an incredible and important trait. They're based on engineering. Engineering is at the base of these companies. Software and hardware is really important here. And they have also the ability to appeal to global markets with a global mindset from the start. They expand across the world and reach new markets. So Sweden has made its weakness, its smallness, into its strength. So we have a global approach from the start. And also we're very happy to say today that we are a very global business environment. For instance, in Morozukkuri in Sweden, we have more than a third of the employees are in foreign companies. That's working very well. And we're also very proud to have a large number of Japanese companies manufacturing in Sweden, such as Denso, Komatsu, Toyota, Yaskawa, and Toshiba. The Swedish government has decided to put a very, very heavy focus on connected industry and smart industry. For many years, manufacturing has been taken for granted. Everyone assumes that manufacturing is there, it's developing, but things are changing. We have to speed up development, and we cannot take it for granted. Things are happening, and we have to pull our resources together. And also, the Swedish attitude is that, yes, industry has created problems with environment and other things, but we think industry is a solution to these problems. Without industry taking the next steps in development, we cannot solve these problems. We cannot solve the climate crisis or urbanization or future transport. It's impossible. So we need industry. So the most important jobs in the future is in industry, is in manufacturing. So for the future kids, they should join this sector. The Swedish strategy is divided into 4 themes on digitization, sustainability, skills, and innovativeness. And very briefly, I could start off with skills. Human skills is really essential to be able to make this transition. So that's why the government has boosted funding for university training, for more engineers, but also vocational schools, and not least for adult education. So we're adding tens of thousands of new places for people which are adults in the working life to retrain, to add new skills to their careers, to learn about new robotics or 5G communication, to learn about artificial intelligence when they are already working out there in manufacturing. We're also adding technological subjects in schools and even for small children. So now from 2018 and forward, even kids from 6 years and up will learn programming, coding, software development. So everyone might not become a developer of software in the future, but everyone should know how computer works, how IT works.
Oh.
In digitization here, we see that we call it Industry 4.0 as digital aspects. We're working with both the most advanced development, pushing the limits of what's possible, self-driving cars, etc. But we're also working with the base, the small companies, the family-owned companies, the suppliers down in different tiers. They have to move as well. They have to develop as well. We need a good ecosystem of suppliers and the OEMs. That's a big focus as well. And there we see that for the top and for the bottom, it's not about only Kaizen. Kaizen is not enough. We also have to learn Kaikaku. We need a radical change as well, radical improvements and more big steps. If we lose ourselves only in incremental change, that's we will move too slowly. We've heard these topics earlier today as well. We see that this is really the foundation of the technology development now. And they are all important because without them, the others will not work. AI, artificial intelligence, is the intelligence, it's the analytics, the big data. We need that to make smarter decisions. But first, we need the data. So we need the IoT sensors, the IoT devices, all over the factories, all over the production systems. But we need the data fast. We need it in ultra high speed with very low latency. We need it in fast communication, so high bandwidth as well. And we need it in long distances and all over the place. So we need the next generation of communication technology. We need 5G to be able to implement IoT, to be able to implement AI. And as you know as well, 5G is both cloud and edge computing, which is also essential to realize manufacturing of the future. And speed is, once again, without speed, the other things don't matter. So we have to move forward fast. It's not enough to only do basic research. We have to also work simultaneously with applied and implementation. We cannot wait years before our research is perfect and then implement. We need to implement continuously. And as others have stressed today, international partnerships is essential. Sweden, as a small country, have been cooperating with other countries for hundreds of years. Here are some recent new partnerships, for instance, with Germany and with France, with Emmanuel Macron of France. And we're also hoping to work more closely together with Japan, that we think is a great manufacturing country, and there's a lot of potential from collaboration. No single country can do this by themselves. We have to collaborate much more closely together to be able to move forward. I'd like to provide very briefly also three examples. One example of an advanced testbed. We have many testbeds in Sweden and in the world, but you also know that a testbed is not the solution to everything. The testbed has to be relevant. Many testbeds are collecting dust and not being used, so they have to be useful. One testbed being developed now and also being actually implemented is 5GEM, 5G-enabled manufacturing, so a connected factory with 5G, which is done by SKF, the world-leading roller bearing company, with Ericsson, a telecom communications manufacturer, and Chalmers University. So they have implemented in a pilot factory first, 5G communication, tested everything, inviting startups with new IoT sensors, etc., applying AI, predictive maintenance, so they can test it in a secure environment. And then now, they have moved it to the real factory. So it's not an idea, it's actually being done. It's been delivered already. So it's quite an inspiration. And in this test bed, you can fail. You can fail in a smart way, and you can learn. You can fail in a secure way, and you're not losing billions of dollars or millions of dollars. So it's very good. And this is also something we've heard before today, startup collaboration with the corporates, with the big companies.
Second policy.
Yes. So this is my second example. Ignite Sweden is a program that we've been running for some time now, which is doing tailor-made matching between relevant startups, which is scouted for, and then we bring them to the big corporates. They want to find collaborations. This has been very successful. And actually, we've even had a number of Japanese companies coming from Japan and Tokyo to Sweden to do matchmaking. So we had Denso, Murata, Komatsu, Sony, and Toyota doing successful matching with small companies. And this is hard. It's easy to say, hard to do. And we see many examples in history when the corporates are like vampires, sucking the blood from the startups.
Vampire.
That's not sustainable. They have to be partners, have to work together, and that's hard. If you have a company which is 100 years old, 100,000 employees, it's hard to work with a startup with 10 employees, but they have to. Otherwise, they would be too slow. So you're also welcome to join in the future. And this is more the working with the base. This is the digitalization lift, lifting the basic level of digital skills in the small SMEs in Sweden. So this is to reach thousands of companies out there, the ones that are not advanced, not in the cutting edge, but the ones that are lagging behind. And we have many companies like that in Sweden, in Germany, in Japan, everywhere. We have those family-owned companies. And they have to be boosted as well. They have to start using digital technologies. So we're doing that through coaching, advisory services, and online support in different ways. And it's been actually very successful so far. So we did it in a pilot phase, and now it's scaled up to the whole of Sweden. That's all for me. Thank you very much.
Thank you. Thank you very much. Thank you. So the industry policy consists of the testbed and the startups, and the digital lift for small and medium-sized enterprises. Very interesting here. So, あと5分ぐらい we have 5 minutes remaining. So let's move on to the third point, the expectations for Japanese companies and the Japanese government. So what's Dr. Roman Hori of Czech Republic, could you comment on the Japanese company or the Japanese government? Expectations.
Expectations from Japanese companies?
Yes.
Yeah, I think that's simple. I see Japanese companies and industry like global leaders, and I suppose they will stay like that, and I just hope that they will not be active mainly at home in Japan, but worldwide. So also in the Czech Republic, because I'm sure that every country, every company has something to offer. And of course, it's for the small country as the Czech Republic, it's difficult to compete with the big countries like Germany or Japan. But we can see in the Swedish example that it's possible. And I think our motto could be something which is motto of a Škoda Auto company, car company, simply clever. So we could be like small and clever.
Yeah, thank you. So how about Mr. Johan? How about?
Yes, I think also it's very impressive to see the Japanese manufacturing companies which have a very high level of digitization as well, and pushing the limits of what's possible. Particularly in robotics, it's very, very inspiring. And we also know that the Japanese engineers have a really high degree of craftsmanship, or expert craftsmen, are very, very talented at that.
Thank you.
But I think as well, Japan and Sweden and many others, we have a big challenge. It's not going to be easy. We have to take up the speed. We have to work in collaborations, which we haven't done before. So that's also a new thing for Japan to try and develop that. And of course, to learn to fail and to move forward.
Yeah. Thank you. So how about Marco Bordini?
As well,
yeah.
some
Same
recommendations. Yes.
Yeah.
So I would sum it up to, as they call it in the internet industry, the API economy is going to dominate also in the manufacturing sector. And with the API economy, without getting into the technicalities of an API, but the concept of how easy and convenient it is to connect with your services from the outside, this will impact directly the rate at which you grow. So this country has excellent technical competences, has all the, it's definitely in a position to still be a world leader, but both culturally and technically exposing your inner workings and your services to the outside might be a challenge.
Maybe the global ecosystem is a key word, you mean? Thank you. So, how about Ms. Lee Haifa from China?
Yeah.
Could you comment on that?
Actually, Mr. Johan Howard introduced, I am impressed by one slide. Yes, Japan, Sweden. Yes, in the top 10 level is competition index. Yes. Sorry, I didn't find China. Okay. Yes, actually, I think yes, Japan is a very developed. The manufacturing level is very high level. I think we have lots of things to learn from Japanese enterprises. It's not only the technology, but also maybe management, this factory management, a lot of things. And yes, according to my, personally, I think to suggestion to Japanese enterprise and government, I think local and international cooperation are quite important. First, for local, yes, I think the situation in Japan, yes, factory, and the situation in China are quite different. Because in China, where we invested, there are maybe lots of legacy technology, maybe some such kind of factory are. But I think in Japan, the manufacturing level are maybe very high level, is very advanced system has deployed. And so I think how to, yes, for Japanese enterprise, how to meet with your local requirement is quite important. Another side for the business model, maybe some business model are maybe make success in Japan, but maybe it's not suitable to China and to other countries. So local service and local solutions are quite important. And another aspect, international cooperation is also important also. I have realized that RI and maybe Japan has cooperate with lots of countries. In future, we think is maybe the collaboration manufacturing, maybe in the worldwide, not only in the country level, inside of the country. So it's quite important for the interoperability and lots of kind of things. So we expect to cooperate in future. Maybe we also welcome more and more. China is a very big market. We welcome Japanese enterprise, maybe,
Thank you.
yes, to China also, and to enhance our cooperation further. Yes.
Thank you.じゃあ石熊さん最後にMr. Shikuma, could you comment on that?
Okay, now let me switch to English. Okay, thank you very much for all the comments towards my presentation and also the expectation for the Japanese industries. I noted the three things by hand. The first thing is I think for ourselves in Japan, Japanese industries, all the manufacturers and associations and organizations need to think more about the business view and a business such a model internationally and locally, maybe. As I said before, the people in Japan intend to, in my opinion, to think of the technologies, what we can do for the upcoming, for instance, 2-3 years. Because this is a Kaizen. But not only the Kaizen, we're talking about the vision in the 10 years later, 15 years later, 20 years later. So as you said, not only the Kaizen, but the Kaikaku is really important. This is a new, relatively new mindset. We have to talk to ourselves one more times. So this is one thing. And the second thing is the, yes, can I Can I see my presentation slide? 私のプレゼンスライド出せますでしょうか、スクリーンに。Is the corporation, international corporations. Yes. Now, in the past, I would say more and more such as Japanese companies, industries, trying to do something by themselves. But as this morning's session, the ministry and other presenters said that the cooperative work will be needed more and more. So I think such industrial corporations, collaboration will be needed, and maybe supported by the standards or something like that, and the common technologies. Yes, we have to have such a, so to speak, a collaboration area, 協調領域 in Japanese, in order to promote all the other industries, other countries, valuable technology and solution to be delivered to all of the worldwide. So this is really the nice idea, and we have to, the Japan side also has to contribute and invest a lot in these areas too, 協調領域 collaboration area. The third is the human. Yes, human also mentioned. Yes, especially in Japan, the number of the workers will be diminishing. So we have to think that this particular country has to think of the 3 times more the productivity in the coming 10 years per person. So this is a really the big, huge, let's say, the problem, I would say. So, but yes, now there's such a suriawase, takumi no waza, such a things. Now the time to be automated, autonomously executed by some automation technologies and so on. And the people have to shift more and more such a creative area, to create something which AI cannot do, maybe. In the future, could do. But the human must shift its role from what we have now to something new, such creative things in the future. This is also my understanding and one of the missions that Japan has to think of from now. Thank you.
Thank you. Thank you. もう時間がちょっと押してまして。
We're have very limited time left, but just before we end, 4 points as coordinator, I would like to do some summarization. Sorry, I'll be speaking in Japanese. First of all, the IoT Industry 4.0 are about systems. I think we all understand that today. It's not just about something that will happen in the factory. Startup, SME, everything has to be involved. Second of all, the role of the government and the role of university are very important. In industrial campus, global open the university is an area that's global and open. That's where this kind of things happens. And also, how do we use the funds of the private organizations, risk money fund? We need to build a good scheme for that. And also, the speed is very important. Those are things that we learned today. Sorry that we are running out of time, but please send a big applause to the panelists. Panelists and moderator, thank you very much.